Good day, I'm Dr. Ting. In this short video clip, we're going to run one-way ANOVA. What is ANOVA? ANOVA stands for Analysis of Variance. Variance means differences. It is a statistical test used to analyze the difference between the means of more than two groups. In order to run one-way ANOVA, your dependent variable must be continuous, interval or ratio, and your independent variable must be categorical, two or more groups. And your subjects in one group cannot appear in another group, or your subjects in one group cannot influence another group, which also means that these groups' subjects are actually identical. Take note that although one-way ANOVA is very similar with independent two samples t-test, in which both of these are actually comparing the means for two groups. However, independent sample t-test only tests for two groups, but one-way ANOVA can compare the means for three or more groups. Let's take a look at this example. Let's say if you want to find out whether there is a significant difference in sleeping hours among the students of different programs. And let's say we have three programs here: the RSF program, RST program, and RAI program. And this will become the independent variable in which we'll have three groups. Whereas for the dependent variable, it will be the hours of sleep. So when you collect the data, RSF group, they will have a set of hours of sleep. Whereas for RST student, they are going to have their own hour of sleep that you collected. And REI, they will have their own hour of sleep collected. And when you compare the difference between the groups, you are going to compare the means of hour of sleep of RSF compared to RST means of hour of sleep, and compare with REI means of hours of sleep for this group. So this variance between group must be larger than the variance within group. Variance within group means the difference between the hour sleep between this student in the same group. So the hour of sleep between here must be smaller than the variance of the hours of sleep between the RST and REI group. And therefore, F will be larger than 1.0 if the means of the RSF group is actually higher as compared to RST, REI. The means is different, it's larger. The difference is larger than the variance within the group of each. Each of this group will have smaller variance within the group of the hour sleep. And therefore, F will be larger than 1.0. If it is larger than 1.0, then there is a difference in the sleeping hour among the students of different programs. And it will be significant if the SIG is smaller than 0.05. The SIG is smaller than 0.05. Let's take a look at this case study, and we're going to run the one-way ANOVA based on this case study. Let's say we have three different groups of people here: non-smoker, past smoker, and current smoker, and we ask them to run for one distance. Then we're going to take their spring time to run that particular distance. The null hypothesis is that there is no difference in spring time between smoker and non-smoker, which are these three groups of people, whereas the alternative hypothesis is that there is a significant difference in spring time between non-smoker, past smoker, and current smoker. So there are three groups here in this one-way ANOVA test. Let's run the one-way ANOVA based on the case study. Go to File, Open, and look for one-way ANOVA dataset. Open, and you'll be able to see that the spring time here, which is in numeric, and also the smoking, in which you have 0, 1, 2. So 0 means that you are going to have non-smoker, 1 means past smoker, and 2 means current smoker. Go to data view. You'll be able to see that actually under the spring, there are some missing value here and there. No worries, because when you run the one-way ANOVA, automatically they will filter or delete this missing record. So go to Analyze, Compare Means, One-way ANOVA, and we're going to select Dependent and the Factor. The dependent will be the spring, and the factor will be the smoking, whether you are smoking or not. You can take a look at the descriptive as well if you would like to, and then run the result. Let's check the result here. Based on the descriptive result, the total amount of valid cases that they input into this one-way ANOVA is actually 353. But actually, in this statistic, we have more than 300 cases. So automatically, they are going to filter out the missing value. If you want to include the missing value, you can actually do the data analysis or data transformation to fill in the missing value by using means or average. Now let's take a look at one-way ANOVA here. The F is larger than 1.0 and SIG is smaller than 0.05, which also means that there is a significant difference between the means of screen time between these three groups of smoker, non-smoker, and past smoker. So we are going to reject the null hypothesis and accept the alternative hypothesis in which there is a significant difference in screen time between smoker and non-smoker. That's all for the one-way ANOVA test. Thank you for your attention.